All right, so this is the key to version 2 of test 1. And so in the first problem, you wanted to solve this linear equation. Now to solve a linear equation, in this case, notice that there's some variable expressions inside parentheses. And so to get rid of the parentheses, notice that this variable expression would be multiplied by 3, this variable expression would be multiplied by 2, and this variable expression here is being multiplied by 6. Not 3 plus 6 is 9 and then multiply by 9. That's incorrect. So remember, order of operations. You have to multiply before you add. So in each of those cases, to get rid of the parentheses, we're going to use the distributive property. So we're going to multiply every term in here by 3, and we're going to multiply every term here by positive 2, and we're going to multiply every term here by 6, not 9, because remember, order of operations. I have to multiply before I add. All right, so using the distributive property, I get 3 times 3x is 9x. And then 3 times a negative 5 is a negative 15. 2 times 4x is 8x. And then 2 times 3 is 6. Equal, and then 3. And then 6 times x is 6x. And then 6 times a negative 1 is a negative 6. All right. Now notice I went from these set of expressions here to 4 terms. So these are equivalent. Now we're going to add like terms. So to combine like terms, notice that like terms are terms that have in this case, these two here, 9x and 8x, are like terms because they both have the variable x raised to the first power. So they have the same variables raised to the same power. So 9x plus 8x is 17x. And then the constants, a negative 15 and a positive 6 is a negative 9. And if you forgot how to add signed numbers, then just use your calculator. So here's your negative button right here. So negative 15, and you're adding 6, and you're going to get a negative 9. Equal. And on this side, the only term involving the variable x is 6x, so I'm going to just rewrite this over. And then 3 and a negative 6 is a negative 3. Okay? All right, again, use your calculator if you have to. 3 plus a negative 6 is negative 3. Or you can say 3 subtract 6, right? Because you can think of this as 3 subtract 6. 3 subtract 6 is negative 3. All right, now, when solving a linear equation, you want to bring all the variables one side, constants the other. It does not matter which side you do this. But I'm going to go ahead and bring the variables to the left-hand side. It'll make things easier. So I'm going to subtract 6x from both sides. See, adding if you said add 6x, that's not going to help. Mathematically, it's a valid property, but it's not going to help you because 6x plus 6x is 12x, and that doesn't help to bring the variables to the left-hand side. So you got to do the opposite. 6x and a negative 6x, when you combine those, is 0. 17x, notice I'm aligning my like terms. 17x minus 6x is 11x. Minus 9 equal 0 and a negative 3 is a negative 3. To get 11x by itself, right now I'm subtracting 9. The opposite of subtracting 9 is to add 9. So we're going to do it to both sides. So what you do to one side, you do to the other. When I combine like terms, a negative 9 and 9, 0, I get 11x is equal to negative 3 plus 9 is a positive 6. And then I'm going to go ahead and just rewrite it over here. Okay, now I've got to get x by itself. So right now I'm multiplying x by 11. The opposite of multiplication is division. So you can divide both sides by the coefficient. Notice only the coefficient. Don't say divide by x. You're not going to get full credit because that's not correct. You divide by the coefficient. Coefficient is x. I'm sorry, the coefficient is 11. So 11 divided by 11 is 1. 1 times x is x. So you want x here. Equal, and then 6 11s. And that's it. So as long as I did the work correct, this is my solution. Notice the work. You have to show all work to get all the points. Don't skip any steps. Okay, number 2. So number 2, we have this linear equation, except this time you have denominators, so to speak. Now over here, when you looked at the original, this linear equation here, you didn't see any fractions, right? You just saw a very nice, clean linear equation. Here, though, you see some fractions. And so what we want to do is we want to clear those fractions. We want ones here. We don't want a 2, we don't want a 3, we don't want a 2. We want this to be ones. So when these are ones, we can then make it look like number 1 up here. And to do that, though, in order to get that to be ones, we're going to have to multiply both sides by the least common denominator. And so the smallest number that 2, 3, and 2 go into evenly is 6. So to clear those fractions, to get those to be factors of ones, we're going to have to multiply both sides by 6. So I'm going to go ahead and rewrite this over. And when I do that, I'm going to go ahead and then multiply both sides by 6. Notice on the left-hand side, I have these two rational expressions. So I'm going to enclose that in brackets, just like this, because remember that we have to multiply both sides by 6. So when I multiply both sides by 6 like this, I now know that I'm going to have to use the distributive property, and each of those rational expressions has to be multiplied by 6. So that's the point of putting those brackets there. And so now when I use a distributive property and I get rid of those brackets, I'm going to get 6 times 2x minus 3 divided by 2, so 6 times this fraction, subtract 6 times the other fraction, so 6 times x plus 6 divided by 3, equal, and I'm going to just go ahead and rewrite this one over. Okay, now let's reduce. So remember, the whole point of multiplying both sides by the least common denominator is to clear those fractions, is to get each of these denominators to be factors of 1. And when I reduce, I do, because look, 2 divided by 2 is 1, 2 divided into 6 is 3. 3 divided into 3 is 1, 3 divided into 6 is 2. 2 divided by 2 is 1, 2 divided into 6 is 3. Okay? So notice all these are 1s. Now, you have to rewrite this. Notice that this expression here, 2x minus 3, is being multiplied by 3. So it's multiplication. So every term here has to be multiplied by 3. X plus 6, every term that's in x plus 6 has to be multiplied by this, and let's think of this as a negative 2. And then 3 times 3 is 9. So the point being that when you write that next step, you need to write it like this. You're going to say 3 times, in parentheses, 2x minus 3, because all of this has to be multiplied by 3. Subtract 2 times x plus 6. X plus 6 in parentheses. And then that's going to equal 3 times 3, which is 9. And notice that this looks like number 1. And now we're going to use a distributive property again. We'll multiply all these terms, in this case by 3, and in this case by negative 2. So 3 times 2x is 6x. 3 times a negative 3 is a negative 9. A negative 2 times x is a negative 2x. And a negative 2 times 6 is a negative 12. And that equals 9. Combining like terms, 6x subtract 2x is 4x. A negative 9 and a negative 12 is a negative 21. And that's equal 9. To get x by itself, right now I'm subtracting 21. The opposite of subtracting 21 is to add 21 to both sides. When I do that, I'm going to get 4x equal, this is 0. 9 and 21 is 30. Okay, now I'm going to go ahead and rewrite this over. So to get x by itself, right now I'm multiplying by 4. The opposite of multiplying by 4 is divide by 4. But remember, you have to reduce. So you have to say both of those are divisible by 2, so that's 15 halves. So you're going to write the solution as x equals 15 halves. Don't write as 34, so you need to reduce. Now, you could, since this is an improper fraction, you can write as a mixed number if you want to. So 2 into 15. 2 goes into 15 7 times. 7 times 2 is 14. Subtract, you get 1. So you can write this as 7 and 1/2. So either one of those is fine. Okay? All right, so that was number 2. Number 3, this time you have a rational expression. Notice you have variables in the denominator. And you had to find the least common denominator, and you had to tell me what that was, and you also had to tell me the restrictions. You had to indicate the restrictions as well. All right, so when finding the least common denominator that involves variable expressions, you need to first of all factor all of these denominators. So x plus 4 is a linear factor, and the GCF is 1. So I cannot factor that any further. X minus 2, I cannot factor further, but this quadratic expression I can factor. Now remember, what usually works is that when you have this quadratic expression, the factors here are normally, not always true, but are normally going to be the factors you see here. So what that's saying is that when you factor x squared plus 2x minus 8, it is going to possibly be the product of these factors, x plus 4 times x minus 2. And notice when you check it, it is the case. So look, x plus 4 times x minus 2. So when you FOIL this, x times x is x squared. The outer, x times negative 2 is a negative 2x. The inner, 4 times x is 4x. And the last, 4 times negative 2 is negative 8. Combining like terms, the outer and inner are like terms here, you get x squared, and negative 2x and 4x is 2x, and minus 8. And notice this is this. All right. Now let's go ahead and find the LCD. So the LCD is going to be a product of factors, and it'll be the factors that you see in those denominators. So I see an x plus 4, that's going to be a factor in my LCD. I see an x minus 2, it's going to be a factor in my LCD. Notice though that remember the LCD is a product of factors, so don't put a comma here. That's incorrect. It must be a product of factors. Then we go to the next one, we see another x plus 4, but I already have it. Don't list it again because it's no longer the least. It's a common denominator, but it's not the least. So if you already have it listed, leave it as it is. And then x minus 2 is already listed, and so we're done. So the least common denominator is a product of these two factors. Now let's find the restrictions. So the restrictions is the value of the variable that makes the denominator 0. Because remember, if this denominator is 0, 3 divided by 0 is undefined. So you're asking yourself, where's my denominator 0? So when I think about this, x plus 4 is equal to 0 when x equals negative 4. So there's one of your restrictions. So x cannot equal negative 4. Over here, x minus 2 is equal to 0 when x equals positive 2. So you're just solving this linear equation. So there's the other restriction. X cannot equal a positive 2. When you go over here, x plus 4, we already have. X minus 2, I already found the restriction. So notice that there are two distinct factors here. So those are the restrictions. Two restrictions. Okay? All right. Now, just like in the previous problem, we want to clear those fractions. So we're going to multiply both sides by that least common denominator. So I'm going to go ahead and rewrite this over. So I have 3 divided by x plus 4 plus 2 divided by x minus 2 equal. And then when I rewrite the left-hand side, I'm going to put this in factored form. So it'll be 5 divided by x plus 4 times x minus 2. All right. And just like the previous problem, we're going to multiply every fraction that's on the left-hand side by that least common denominator. So x plus 4, x minus 3. So what I do to the left, I do to the right. X plus 4 times x minus, oops, that's supposed to be 2, sorry. X minus 2. Okay, now let's go ahead and get rid of the brackets. So remember, we're going to use the distributive property. So this LCD is being multiplied by that first fraction, and we're going to multiply the LCD also by the second fraction. And so your step's is going to look like this. X plus 4, x minus 2, times 3 divided by x plus 4, plus, and then x plus 4, x minus 2, times 2 divided by x minus 2, equal. And then I'm running out of room here, so I'm going to go ahead and just reduce this. So these x plus 4s divide out, and these x minus 2s divide out. So remember, that was the whole point. So the whole purpose of multiplying both sides by the LCD is to get all these fractions down here to be factors of 1. And so notice that 1 times 1 is 1. So I'm done here. So that's 5 times 1, which is 5. Reducing the left-hand side, the x plus 4s divide out, and then the x minus 2s divide out. So again, the whole point of multiplying by the LCD is to get factors of 1s. Now, notice right here, we have 1 times x minus 2 times 3. 3 divided by 1 is 3. Remember, multiplication is commutative. The order in which you multiply does not matter. So I'm going to do this. 1 times 3 is 3. And then 3 is going to be multiplied by x minus 2. So this becomes 3 times x minus 2. Plus, same thing here. 1 times 2 is 2. And then we're going to multiply 2 by x plus 4. And then that's going to equal 5. So notice I went from this rational equation to a linear equation. So let's solve this linear equation. So to solve this linear equation, we're going to distribute. We use distributive property first. So 3 times x is 3x. 3 times a negative 2 is a negative 6. Positive 2 times x is 2x. And then positive 2 times 4 is a positive 8, equal 5. Combining like terms, 3x plus 2x is 5x. A negative 6 and a positive 8 is a positive 2, equal 5. And then to get 5x by itself, right now I'm adding 2. The opposite of adding 2 is to subtract 2 from both sides. Combining like terms, this is 0. 5x and 0 is 5x, equal, and 5 subtract 2 is 3. And then to get x by itself, notice you're multiplying x by 5. The opposite of multiplying by 5 is to divide by 5. And I get x to be 3/5. Okay, now, be careful. So this 3/5 is a solution to this linear equation. But the question is it a solution to the rational equation, the one that had variables in the denominator? So all you have to do is ask yourself, is 3/5 going to make any of the denominators 0? So in other words, is 3/5 a restriction? And it's not. So if as long as I did this correct, then this solution here, which is a solution to this linear equation, is also going to be a solution to the rational equation because it's not a restriction. Now, if you did all this work and you got x to be, let's say, 2, notice that 2 makes this denominator 0. 2 divided by 0 is undefined. See that restriction? So 2 would not be a solution, and then you would just say no solution. All right, but 3/5 is not a restriction. So as long as it does this work correct and notice the work, you have to show all this work, then you're good. All right, number 4, you want to solve this quadratic equation. And you're going to solve this quadratic equation by using the square root property. So to get this variable expression here, 4x minus 3 by itself, notice that I'm squaring 4x minus 3. I'm going to go ahead and rewrite this over first. And so the opposite of squaring is to take the square root of both sides. But remember, when you take the square root of both sides, you're going to do that plus or minus. You're going to need that plus or minus symbol. So when you take the even root on both sides of an equation, you do that plus or minus. And then when I simplify this, I remember the fact that the square and the square root undo each other, and then you're left with this variable expression, 4x minus 3, equal plus or minus, and then we have the square root of a negative 25. Well, remember, we learned that the square root of a negative 1 is defined to be that imaginary unit I. So then, the square root of a negative 25, I know I can write as the square root of a negative 1 times the square root of 25. And the square root of a negative 1 is defined to be the imaginary unit I, and 25 is a perfect square, and the square root of 25 is 5. So I times 5 is just 5i. So then this becomes plus or minus 5i. Now, I'm going to end up with imaginary solutions. So the best way to solve for x here is to put this in compact form. So first of all, we're going to add 3 to both sides. And when I do that, combining like terms, I get 4x equal. Now be careful, these are not like terms, so don't say 5 plus 3 is 8. That's incorrect, because that's not an I here. Okay? So those are not like terms, so the way to write this is to say 3 plus or minus 5i. Just like that. And then to get x by itself, let me just then rewrite this over. And so then to get x by itself, right now I'm multiplying x by 4. The opposite is to divide both sides by 4. And when you do that, you're going to get x equal 3 plus or minus 5i, that's a 5, divided by 4. And leave your answer like that. You're good. Now, what some students want to do sometimes is to write them separately. See, there are two solutions. See that plus and minus? So one of my solutions would be 3 plus 4i divided, 5i rather, divided by 4. And the other is 3 minus 5i divided by 4. All right, so that's number 4. Notice you have to get all your points, you have to show all these steps. Number 5, we have this quadratic equation, except this time you want to solve this by factoring. And so if I'm going to solve a quadratic equation by factoring, I need to put this in standard form. So meaning that I want 0 on the other side. So we're going to bring the 8 over, and we're going to put it in descending order. When I do that, I'm going to get 3x squared minus 2x minus 8 equal 0. And so to factor this, the GCF here is 1, so I'm going to go directly to the product of two binomials. Now 3x squared, 3 is a prime number, so I know that the only factors that's going to work here will be 3x and x. Now let's talk about 8. So to get 8 here, I'm going to need 4 to be here and 2 to be here, because 4 times 2 is 8, right? And 8 times 1 is 8, but 8 and 1 is not going to work. So the only thing that's going to work is 4 and 2. And 4 would have to go here, and 2 would have to go here. Now the last sign's negative, so remember that means that these signs in here are different. One's positive, one's negative. And we need to make sure that we put this correctly, because I need that middle term to be a negative 2x. And the only way that's going to work is for this to be negative and this to be positive. And before we go on, always check. So let's check and see if what I have here is correct. So we have 3x plus 4 times x minus 2. So let's follow this to make sure I get 3x squared minus 2x minus 8. So 3x times x is 3x squared. The outer, 3x times negative 2, is a negative 6x. The inner, 4 times x is a positive 4x. And the last, 4 times negative 2 is a negative 8. Combining like terms, I get 3x squared. A negative 6x plus 4x is a negative 2x, and then minus 8. And notice this is what we wanted. Okay, so I factored correctly. Now remember, you have two factors whose product is 0. So the zero factor property says that if you have two or more factors whose product is 0, the only way that product can be 0 is if one of those factors is 0. So to do that, the next step would be to set each of those factors equal to 0. And then notice I went from a quadratic equation to 2 linear. So we're going to subtract 4 from both sides. So I get 3x equals negative 4. To get x by itself, I'm going to divide both sides by 3. And when I do that, I'm going to get one of my solutions to be negative 4/3. Over here, this is just x equal 2. So those are your solutions. So your solutions are negative 4/3 and positive 2. In number 6, you want to solve this quadratic equation by using the quadratic formula. Notice that, remember, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac. All of that, so you had to go from negative b to the end of that radical symbol is being divided by 2a. So there's the quadratic formula. And when using quadratic formula, you want your quadratic equation in standard form. So you want 0 there, it is there. And you want to put it in descending order, which it already is. So we need to determine the values of a, b, and c here. So a, remember, is the coefficient of x squared, so that's 2. b is a coefficient of x, so that's a positive 4. And c is your constant, so that's a negative 3. And then we're going to take each of those values and substitute into the formula. So I'm going to get x equal. And remember, this says the opposite of b. So b in this case is 4. The opposite of 4 is a negative 4. Plus or minus the square root of b squared. So b is 4. And put that in parentheses. I'm going to square it. So remember, b squared is always going to be positive or 0. It's never going to be negative. Remember that. And then you're going to subtract 4 times a, which is 2, and then times c, which is negative 3. All of that, so remember, I'm looking to see how you write your symbols. So all of that's going to be divided, so going from negative 4 all the way to the end of this radical symbol is going to be divided by 2 times a, which is 2. Now remember, this b squared minus 4ac in the quadratic formula, that's called the discriminant, but in general, whenever you have a radical, it's called the radicand. So the first thing we're going to do is we're going to simplify this radicand. So 4 squared is 16, so this becomes negative 4 plus or minus the square root of 16. A negative 4 times 2 is a negative 8, and a negative 8 times a negative 3 is a positive 24. All of that is being divided by 2 times 2, which is 4. So notice going from negative 4 to the end of the radical. 16 plus 24 is 40, so it becomes negative 4 plus or minus the square root of 40 divided by 4. All right, now we got to simplify the radical whenever possible. So let's think about the square root of 40. So besides 1, 4 is a perfect square that goes into 40. So I can simplify this. So this becomes the square root of 4 times the square root of 10. 4 times 10 is 40. And 4 is a perfect square, and the square root of 4 is 2, so it becomes 2 square root of 10. So that's going to go here. So it becomes negative 4 plus or minus 2 square root of 10 divided by 4. And I want you to notice that this negative 4 and this 2 here that you see and this 4 are all divisible by 2. So I can simplify this expression further. So negative 4 divided by 2 is a negative 2. Plus or minus 2 divided by 2 is 1. 1 times the square root of 10 is the square root of 10. All of that's being divided by 4. 4 divided by 2 is 2. And that's your answer. So that's your solution. Now, if you want to write this as two separate solutions, you can. You could say negative 2 plus the square root of 10 divided by 2, comma, negative 2 minus the square root of 10 divided by 2. That would have been fine as well. Okay, number 7. Number 7, we have this polynomial equation. Notice there are 4 terms. And the way you want to do this to solve this equation is to see if you could solve by factor by grouping. And usually what works, not always the case, but usually what works is to group the first 2 terms and group the last 2 terms. First of all, make sure it's in descending order, and it is. And so from that first group, I noticed that the GCF here is x squared. So I'm going to factor out an x squared. So basically what I'm going to do is I'm going to take these 2 terms and I'm going to write as a product, the GCF times some expression. So x squared times 3x is going to be 3x cubed. And then over here, subtract, and then x squared times a negative 2 is going to be a negative 2x squared. So I took this first group and I wrote as a product of the GCF times a variable expression. Do the same thing here. So if you look at these 2 terms here, 21x and a negative 14, the GCF is a positive 7. Positive 7. So it's always, if this was negative, you would put this as a negative 7. So, but it's a positive 7 because 7 goes into 21x and 7 goes into negative 14 evenly. Now when I do that though, I'm going to get 7 times 3x is 21x, and then 7 times a negative 2 is a negative 14 and equal 0. So notice if this original equation is factorable by grouping, then you should have, in these 2 groups here, you should have a common factor. Now, the common factor is 3x minus 2, so I needed to see that next step. I needed to see you say, well, this left-hand side then is going to be a product of 3x minus 2 times, and then when I factor out this 3x minus 2, I'm left with x squared, and when I factor out this 3x minus 2, I'm left with a positive 7. So you had to show that. I had to see this. Then, just like the previous problem, you have 2 factors whose product is 0. So according to the zero factor property, one of those has to be 0. So either 3x minus 2 equals 0 or x squared plus 7 equals 0. And then notice I have a linear equation and a quadratic. This linear equation is easy. That's going to be 3x equal 2. And then divide both sides by 3. I get one of my solutions to be 2/3. Over here, you could use a quadratic formula if you wanted to. But I want you to notice that that since there's no x term, it will be quicker just to bring 7 to the other side, like this. And I'm going to rewrite this over. And then to get x by itself, right now I'm squaring. The opposite is to take the square root of both sides. But remember, when you take the square root of both sides, you get that plus or minus. So then the square and the square root undo each other. So you get x equal plus or minus. Now let's think about the square root of a negative 7. Square root of a negative 7 is the square root of a negative 1 times the square root of 7. Now remember, we learned that the square root of a negative 1 is I. And then the only perfect square that goes into 7 is 1, so the square root of 7 cannot be simplified. And so therefore, this is your two solutions. So there are 3 solutions altogether. So x equal 2/3, x equal I square root of 7, and x equal negative I square root of 7. So either one of those is fine. Now I want to say this, and this is important. Some of you prefer to put the I in the back of that square root symbol. All right, if you do that, you need to make sure it looks like this. Okay? It looks like this, not this. See, that I is under the square root. I cannot be under the square root. It's outside of that square root symbol. So if you did this, that's not correct. We talked about that before. So that's why most students prefer, when they have a square root, prefer to put the I in front of the square root symbol, to put that as I times the square root of 7 instead of, and you could write it like this, instead of this. Okay, as long as the I does not look like it's under the square root of 7. All right, so that was number 7. Okay, number 8, you have this square root equation, and that's the same thing for 8 and 9. Notice, though, that when solving a square root equation, you want to get that square root by itself. So in this case, I'm adding 3, so the first thing I need to do is to subtract 3 from both sides. And so then I get the square root of 2x minus 7 is equal to, this is 0 here, and 8 minus 3 is 5. Okay, now, so the square root's by itself. Now, remember, to get that variable expression 2x minus 7 by itself, I need to get rid of that square root. So I'm going to just go ahead and rewrite this over. So get rid of that square root. Remember, the opposite of taking a square root is to square both sides. So the opposite of square rooting is squaring. So I have to square both sides. So now the square and the square root undo each other. So I get 2x minus 7 is equal to, and then 5 times itself is 25. So notice I went from the square root equation to a linear equation. And so I'm going to solve this linear equation. And when I do that, I'm going to get 2x equal 25 plus 7 is 32. And then divide both sides by 2. I get x to be 32 divided by 2. And then reducing this, 32 divided by 2, using your calculator if you have to, is going to be 16. Okay? So you can say your solution is x equals 16. Now, I want to say this. Whenever you raise both sides to an even power, which is what I did here, I raised both sides to the second power. Remember, you could introduce, remember we talked about this, you could introduce what's called extraneous solutions. So technically, when you raise both sides to even power, you should check for extraneous solutions. In number 8, when I got that screwed by itself, this was a positive 5. There was no variable expression here. But since this was positive, not negative, if this was negative, there would be no solution. But since or 0, as long as this is positive or 0, you're going to get solution. If this is negative, remember you get no solution. But the fact that this side here doesn't have a variable and it's positive, you don't have to check. Notice here, though, number 9, there are variables on both sides. So you do have to check. So you notice when we do number 9, you're going to see me checking for extraneous solutions. But x equals 16 is a solution here. We don't have to check, but if you did, this is what you did. So let's go ahead and check x equal 16. So to do that, we go back to the original. Always go back to the original. So my original was this. So we have the square root of 2 times 16 minus 7. So wherever I saw the variable x, I'm going to substitute 16, plus 3, and I want to see if that's going to equal 8. Well, 2 times 16 is 32, right? So that's the square root of 32 minus 7 plus 3. 32 minus 7, use your calculator if you need to. 32 minus 7 is 25. So this becomes the square root of 25 plus 3. The square root of 25 is 5, and notice 5 plus 3 is 8, and that's what you wanted. So x equals 16 is a solution. Now let's do number 9. Number 9, you're going to have to check for extraneous solutions because there are variables on both sides. Okay, now let me go ahead and rewrite this over. Okay, so just like the previous problem, you want to get the square root by itself, and it already is, and then you want to get rid of the square root. To get rid of the square root, you're going to square both sides. Notice that on the left-hand side, I'm going to put all this in parentheses, and I'm going to square it. Now I'm going to go off to the side. I'm going to figure out what x minus 4 times itself is. So let's think about what x minus 4 times x minus 4 is. So when I FOIL this, I'm going to get x times x is x squared. The outer, x times a negative 4 is a negative 4x. The inner, a negative 4 times x is also a negative 4x. Now remember, when you square a binomial, the outer and the inner should be exactly the same. And then a negative 4 times a negative 4 is a positive 16. Combining like terms, I get x squared. A negative 4x and a negative 4x is a negative 8x, and then plus 16. So that's going to go here. So that'll be x squared minus 8x plus 16 equal, and on this side, the square and the square root undo each other, so you get 3x minus 8. Notice I went from a square root equation to a quadratic equation. So to solve this quadratic equation, let's put this in standard form. So I need 0 here. So we're going to subtract 3x on both sides. Notice I'm going to go ahead and align my like terms. And I'm going to kind of do 2 steps in one here. So the opposite of subtracting 8 is to add 8. So we're going to add 8 to both sides and align like terms. When I combine like terms, I get x squared, negative 8x, and a negative 3x is a negative 11x. 16 plus 8 is 24. Equal, and then this is 0, and this is 0, so I get 0 here. To solve this quadratic equation, I can use a quadratic formula, but it is factorable, so let's go ahead and factor this. So I'm going to factor this as 2 binomials. And what's going to work is that I'm going to have to say x times x is x squared, and 24, there are several possibilities, but the one that's going to work will be 8 and 3. 8 times 3 is 24. 6 times 4 will not work. 8 times 3 will. And I'm going to put the 8 here and the 3 here. And the last sign's positive, right? So that means both of those signs will be the same, and they're both going to be this middle sign, which is negative. Before we go on, though, you need to verify that this product is what you see here. So let's go ahead and multiply that out. Let's just check. Let's just verify that x minus 3 times x minus 8 is going to be what you see here. X times x is x squared. The outer is negative 3x. Negative 8 times x is negative 8x. And the last, a negative 8 times a negative 3 is a positive 24. Combining like terms, this becomes x squared minus 11x plus 24. So what I have is correct here. Then we're going to use the zero factor property because I have two factors whose product is 0. So one of them has to be 0. So I'm going to set both of those equal to 0. And then we're going to solve for x. So notice those are linear. So I get x to be 8 and x to be 3. Okay, now remember, these two solutions, 8 and 3, are solutions to this quadratic. But the question is, are they solutions to this square root equation? Because remember, we raise both sides to even power. So since I raise both sides to even power, I have to check for extraneous solutions. So you have to check this. So let's check. So let's check the first one, x equal 8. And you go back to the original, and where we see the variable x, and substitute 8. So I get 8 minus 4 equal the square root of 3 times 8 minus 8. All right, 8 minus 4 is 4. Now let's look at this side. 3 times 8 is 24. So that becomes, this right here becomes a square root of 24 minus 8. 24 minus 8 is 16, and the square root of 16 is going to be 4, and notice those are equal. So x equal 8 is going to be a solution. So x equal 8 is not extraneous. It is not a false solution. It is extraneous. X equal 8 is a solution. It's not an extraneous solution. Not a false solution. So not only was x equal 8 a solution to this quadratic, but it's also a solution to the original. Now let's check x equal 3. So again, go back to the original, and wherever you see the variable x, I'm going to substitute 3. So I get 3 minus 4, and I want to see if that's going to equal to the square root of 3 times 3 minus 8. Well, 3 minus 4 is a negative 1. Oops, negative 1. Over here, 3 times 3 is 9, so that becomes the square root of 9 minus 8. 9 minus 8 is 1, and the square root of 1 is 1. But notice, negative 1 does not equal 1. So what that means is that even though 3 is a solution to this quadratic equation, it is not a solution to the square root equation. So this is our extraneous solution. That's our extraneous solution. So the only solution to the original is x equal 8. So the only solution is x equal 8. So yeah, you do have to check. Whenever you raise both sides to even power, you have to check for extraneous solutions. All right, so that was number 9. Okay, let's look at number 10. So number 10, we have this linear inequality. And to solve this linear inequality, this is an easy one. We're just, first of all, just use a distributive property. And when I do that, I get 2 times 3x is 6x, 2 times negative 2 is a negative 4, and then 2 times x is 2x, and then 2 times 3 is 6. And that's going to be less than or equal to 4x minus 5. Combining like terms, 6x plus 2x is 8x. Negative 4 plus 6 is a positive 2. It's less than or equal to 4x minus 5. And then we're going to bring all the variables to one side, constants to the other. And so, again, it does not matter which side you bring the variables on. I'm going to just go ahead and bring them to the left-hand side. So I'm going to subtract 4x from both sides. And when I do that, I'm going to get 8x minus 4x is 4x. Plus 2 is less than or equal to 4x minus 4x is 0. 0 minus 5 is a negative 5. The next step is to get rid of this adding 2. The opposite of adding 2 is subtract 2. And so when I combine like terms, I get 4x is less than or equal to negative 5, and a negative 2 is a negative 7. And then to get x by itself, I'm going to divide both sides by 4. And so I get x to be less than or equal to negative 7/4. Okay, now x is less than or equal to negative 7/4 means that any real number less than or equal to negative 7/4 is a solution to the original. In terms of a number line, what that looks like is this. So here's negative 7/4. Since there's an equal sign here, that means negative 7/4 is a solution. So notice the bracket here, the closed circle, or you can use a bracket, doesn't matter. And you're shading at everything to the left. Notice the arrow here pointing to the left. You have to write the answer in interval notation. And so once you have the graph in your mind, and you see that your solutions, and remember you always go from left to right, and you see that this arrow is pointing to the left, that means that your solutions are going to be from negative infinity all the way to negative 7/4. So when you're writing the interval notation, you'll say parentheses, negative infinity, just like this, comma, negative 7/4 with a bracket, because negative 7/4, see that equal sign, is included. Whenever we use infinity, negative infinity, it's always parentheses. Now when writing interval notation, you need to make sure I can tell whether it's a parentheses or a bracket. If I cannot tell, you're not going to get full credit. All right, but that was number 10. Okay, let's look at number 11. Okay, in number 11, we have this compound inequality, and there are two approaches. The most efficient way to solve this compound inequality, remember a compound inequality is where you have more than one inequality symbol. the most efficient way of solving this compound inequality is to get x in the middle. So to do that, we need to get rid of this adding 2. So the opposite of adding 2 is to subtract 2. So we're going to subtract 2 from all parts, the left-hand side, the middle, and the right. A negative 7 and a negative 2 is a negative 9 is less than or equal to, this is 0 here, and we get 3x, and that's less than 9 subtract 2 is 7. To get x by itself now, right now I'm multiplying by 3, the opposite is to divide all parts by 3. So I get negative 9 thirds is a negative 3, is less than or equal to, and this is x, is less than 7 thirds. And so therefore, when you look at this in terms of a graph, this is what you have. The solutions to the original would be any real number that's between negative 3 and 7 thirds. Notice the equal sign here, no equal sign here. So when you're putting this in terms of a graph, since there's an equal sign, that means negative 3 is a solution. So notice a closed circle. Here, there's no equal sign, so that means 7 thirds is not a solution, so notice the open circle. And everything between them, every real number here, which is an infinite, all these rational numbers, all these irrational numbers are going to be solutions to the original. In terms of interval notation, which is what you had to tell me, you always go from left to right. So notice I'm going from a negative 3 with a bracket, because that's a closed circle, there's an equal sign, comma all the way to 7 thirds with a parentheses, because there's no equal sign. 7 thirds is not a solution. But everything between negative 3, including negative 3, and 7 thirds, not including 7 thirds, is a solution. So that was the most efficient way. So that was approach number 1. Some students prefer to use approach number 2. Now, when using approach number 2, you have to be a little bit careful. The students that use approach number 1 usually get all their points. Students that use approach number 2 usually don't get all their points because they're missing something. I'll tell you what they're missing when we get to that point. Okay, so in approach number 2, here's the way students think about this. So when you read this, this reads as negative 7 is less than or equal to 3x plus 2. And notice I'm using the word and at the same time, 3x plus 2 has to be less than 9. So what that means then is that when you rewrite this using approach number 2, you would say negative 7 is less than or equal to 3x plus 2. And that's what you have to write. You had to write the word and. If you did approach number 2 and you did not use the word and, you're not going to get all your points. Because there is a difference between the word and the word or. Those are two different types of statements. So and, remember, means intersection. So you can be looking at the intersection of these two solutions that you end up with. So and at the same time, 3x plus 2 is less than 9. And then what you did was you solved each of those individual inequalities. So let's go ahead and do this one. So we're going to subtract 2 from both sides. So I get negative 7 and a negative 2 is a negative 9 is less than or equal to 3x. And then dividing both sides by 3, I get negative 9 thirds, which is a negative 3, is less than or equal to x. Now, most students do not like, when you have an inequality, do not like x being on the right-hand side. So you can rewrite this to where you have x on the left. So negative 3 is less than or equal to x means x is greater than or equal to negative 3. So that means. Now remember, any real number greater than negative 3 is a solution to this linear inequality right here. That doesn't mean it's a solution to this compound inequality. It's only a solution to this linear inequality. Same thing here. When I subtract 2 from both sides, I get 3x is less than 7. Divide both sides by 3, I get x to be less than 7 thirds. So any number less than 7 thirds, any real number less than 7 thirds is a solution to this inequality. It doesn't mean it's a solution to the original, to this compound. To determine the solution to this compound statement, you have to look at the fact that this is an and statement, an intersection. So in your mind, you're doing this. So here's negative 3. Here's 7 thirds. Make sure you put in the number line correctly. So let's graph this one first. So I'm going to shade in every real number that's greater than or equal to negative 3. Since there's an equal sign, I'm going to use bracket, closed circle. And then any real number greater than that. So what I found here is that any shaded number here is a solution to this linear inequality. Not the original, only this one. Doing this one, here 7/3, open circle because there's no equal sign. I'm going to shade in every number less than that. So what I've shaded in here, that second arrow, that second graph, is a solution to this one. What I want to do, though, is find the solution to the original. And that's where that AND statement comes in, that intersection. The solution to the original is where those two graphs intersect. And so therefore the graph of the solution set to the original will be from where they intersect. So it will be from -3 all the way to 7/3. So -3, a closed circle, 7/3 open circle, and everything between them. And then therefore in interval notation, you go from left to right, so you go from -3 bracket all the way to 7/3 with parentheses. So that was approach number 2. Most students prefer approach 1. It is more efficient. You get the same answer, the same solution, quicker. Don't forget though, if you didn't put the word AND, you wouldn't get all your points. And then finally, number 12, you have this absolute value equation. To solve an absolute value equation, the first thing you want to do is make sure the absolute value expression is by itself, and it is. So this has already been done for you. You got to remember though that when we talked about absolute value, the definition of absolute value, that was the distance that a number is away from 0. So when we talked about it, we looked at the idea of, let's say, 3 and its opposite, -3. 5 and its opposite, -5. So you remember we had those discussions. So when solving an absolute value equation, now I'm going to say this also, this absolute value equation is going to have a solution because this number here, this numerical number, this constant is positive or 0. If this was negative, it wouldn't have a solution. So in other words, if this was 4x minus 3 is equal to -7, that would be no solution. Because remember, the absolute value of a number is never negative, right? So it's either positive or 0. Well, positive or 0 is never equal to a negative. But the fact that this is positive, I can go further. So then the next thing I needed to see was 2 separate equations without the absolute value bars. So you had to write the next 2 statements. So you would say, notice the first one is easy. You would rewrite this without the absolute value bars. So you'd say 4x minus 3 is equal to 7. And then the other one, you would say 4x minus 3. Notice 4x minus 3 is equal to the opposite of 7. So that's where that opposite comes in. The opposite of 7 is a -7. So you have a 7 and a -7. And then you just solve each of those linear equations, and those are your solutions. So we're going to add 3 to both sides. So you get 4x equal 10. Divide both sides by 4. I get x to be, and that's going to be 5/2. Over here, add 3 to both sides. I get 4x equal -7, and 3 is a -4. Divide both sides by 4. I get x to be -1. And you can check this, by the way. So let's just check this, just to show you. See this -1? Let's do -1 first. 4 times -1 is a -4. A -4 and a -3 is a -7. And the absolute value of a -7 is a +7. And then let's check 5/2. 4, let me do that one. Let's do that one here because that involves a fraction. So let's just check x equal 5/2. So I have the absolute value of 4 times 5/2 minus 3, and I want to see if that's going to equal to 7, right? Well, let's reduce this. 4 times 5/2. You can say 2 to 2 is 1, 2 to 4 is 2, right? And then 2 times 5 is 10. Or you could have said 4 times 5 is 20. 20 divided by 2 is still 10, right? So this becomes the absolute value of 10 minus 3. 10 minus 3 is 7. And the absolute value of 7 is a +7. And notice those are equal. So you could have easily checked those. But anyway, as long as the absolute value is by itself, and that's a real number, positive or 0, you're going to get solutions. If this was negative, you would say no solution. All right, but that is it. So that is the key to version 2 of test 1.